everyone, and welcome to our lesson on real numbers. We're going to talk about what kinds of numbers are real, and then we're going to talk about some properties that these numbers will always hold. So this picture here is kind of describing the categories of real numbers that we have. Underneath real numbers, we have two different kinds. We have numbers that are rational and then numbers that are irrational. Rational numbers are the numbers that can be written as fractions if we need them to be. So any kind of whole number, like the number 5, I could write it as 5/1 if needed, or any other kind of fraction. Those are rational. The irrational numbers on the other side are the ones that cannot be, such as some kind of decimal that would continue on forever and not be able to be converted to a fraction. So pi, maybe, the number pi. And then within rational numbers, there are many different categories, but the two main ones that we deal with are integers and whole numbers. Integers are those that are all of the whole numbers, no decimals, on the negative side of the number line and the positive side, whereas whole numbers just begin at 0 and deal with the positive side. Alright, so what are some properties that we can count on every time with real numbers? One of those is called the commutative property, and that says if I add any two numbers together, I can add them in any order and I'll still get the same answer. For instance, think of two numbers such as maybe 2 and 3. If I try to calculate 2 plus 3, I'm going to get the same thing as when I calculate 3 plus 2. Different order doesn't change my answer. So all real numbers are going to have this commutative property. I can add them in any order and get the same answer. Another cool property that they have is called the associative property. And I kind of like to think of that one as who the numbers are associating with. It's about grouping. So if you group two numbers together and add it to a third, you're going to get the same answer as if you were to have grouped the second two together in a group instead of the first two. So let's try it. Let's just take 1, 2, and 3. So if we have 1 plus 2 and add that to 3, we will get 3 plus 3, which is 6. And then let's group the other two together and do that order first. We'd have 1 plus 2 plus 3 together. Okay, so if I add my 2 and 3 together first, I'll get 5, but adding another one still gives me 6. And any three numbers you can think of will still hold that property. Alright, moving on, there is a special number in the real numbers called the additive identity, and it is 0. And if you think of any number in your mind and you add a 0 to that number, you are going to get the same number. So 5 plus 0 is still 5, and any number plus 0 is still that number. And I think of that one, I remember that one by thinking, okay, 0 is the value I can add to it to where it doesn't lose its identity. It doesn't change itself. It's still the same number when I'm finished. The additive inverse, when you think about that term, you can sort of think of the opposite of that number. If I have some number in the real numbers and I add it to its opposite, I'm going to get 0. And that happens with any number and its opposite in the real numbers. So let's take the number 8, add it to -8, and we're going to get 0. Alright, some properties of multiplication here. Let's look at these. Commutative property of multiplication, similar to the one for addition, it deals with the order that you are putting the numbers in. If you take any two numbers and multiply them, you're going to get the same answer as if you switch the order and multiply them in the reverse order. So try it. Let's take our same two numbers, 2 and 3. 2 times 3 gives me the same exact answer as 3 times 2. That will happen every time. You can try fractions or negatives, it's still going to work. Associative property of multiplication works as well, just like it did for addition. If you multiply any three numbers together in any order, it's still going to give you the same answer both times. So you can test a couple of those for fun if you like to. Alright, some more properties that these real numbers hold is that they have a multiplicative identity as well. We talked about the additive identity. It was the number 0 that didn't change the number's identity. And that's going to happen here as well. When you multiply any number by 1, its identity will not change. It will still be that same number. So 2 times 1 will still be 2. Negative 3 times 1 will still be negative 3, and such. Okay, so the multiplicative identity is 1. And the multiplicative inverse is 1 over the number that you're starting with. The multiplicative inverse is going to always multiply by our number to give us 1. So if I take, let's say 7 times 1 over 7, any number times 1 over that same number is going to give me 1. 7 times 1 is 7 on top and bottom, which will be 1. Alright, one more property that we need to look at here is called the distributive property. And if I can think about A, B, and C being any numbers, and I distribute the one outside to the group, that is going to become A times B plus A times C. Let's try it with a few numbers. Let's just try our 1, 2, and 3. Or maybe we should do 2, 3, and 4, just so we've got some bigger numbers there. 2 is A, and 3 is B, and let's call 4 C. Okay, so let's do this without distributing first, just to make sure we get the same answer both ways. So if I do this order, I should do 4 plus 3 first, and then multiply by 2. Which is going to give me 14. Okay, let's try distributing and make sure we get the same answer. Distributive property tells me that I should get the same answer if I multiply my outside number to each member of the group. So that should be 2 times 3 plus 2 times 4. So let's see, that gives us 6 plus 8, which guess what? Gives us 14. So we have a match, which means the distributive property holds true. All right, let's talk about closure of sets. So we're still thinking about the real numbers and all of the properties they have. If you need to find out if a set of numbers that you are dealing with is closed under a certain operation, what you're going to do is you're going to take any two numbers in that set and perform the operation, and your answer should still be a number in that set. For instance, if you're trying to find out if integers are closed under, let's say, addition. Got an example here. If I add two integers together, remember in the integers we have negative and positive whole numbers. So let's take 5 and 4. If I add those, I'm going to get 9. And 9 is still in the set of integers. And now if I can do this with any two integers, that means that this set of numbers is closed under addition. Okay, so you can experiment with this and try to see if different operations hold the same thing, if they're still closed under that operation. If we want to try subtraction, if we take our same two numbers, 5 minus 4, we are going to get 1, which is still an integer. So that means that integers are closed under addition and subtraction. But what about a different operation? Let's test it. Let's try division. So same two numbers, 5 and 4. If we divide them, look what we get here. A fraction, 5/4, which is the same as 1 1/4. Which is not an integer because integers are only whole numbers and negative whole numbers and zeros. So that means for us that integers are not closed under division. And you can try multiplication to see what you come up with just for fun. And this concludes our lesson on real numbers.